Okay, before I get into our third factoring video, I'd like you to pause this and give these problems a try. This is a review over what I covered in the first two videos. So I hope you paused it because here come the solutions. All right, so on number one, I did GCF first because always start with GCF. So I factored out a 2. When I did that, I got 4x squared minus 9. Notice 4x squared is a perfect square. 9 is a perfect square. It's the difference. Difference of two squares. So the 2 tags along. When you take the square root of 4x squared, you get 2x. The square root of 9 is 3, so you have 2x plus 3, 2x minus 3. On number 2, there is no GCF. The coefficient is not a 1, so I had to do the modified diamond in the box. So I got the negative 30 for the product, the negative 7 for the sum. My two numbers are negative 10 and 3. Remember, that's how you tell how to break up the x's. Once you fill in your box, you pull out GCFs, and you come up with your answer. On number 3, notice that the 4x squared is a perfect square. 9 is a perfect square. This is a minus. So I think, this might be a perfect square trinomial. So the square root of 4x squared is 2x. The square root of 9 is 3. And it was a minus, so these would both be minus. Then you can double check with FOIL. So 2x times 2x is 4x squared. The outside gives me a negative 6x. The inside gives me a negative 6x. And when you combine those, you get a negative 12x. And then the last gives me a plus 9. So then you can kind of double check and make sure it works. It does. Your alternate to do this, if you don't recognize the formula, is to do the modified diamond in a box like number 2. On number 4, start with a GCF. You can pull out a 3x, and then you're done. There's nothing else to do. So that was a review of what we did before. Today, we're going to talk about what do you do when you have 4. Now, I want to point out to you, this is not a quadratic because the highest power is a 3. So this is a cubic expression. That because the highest power is a 3. We can also refer to this as, to all of them, as polynomial expressions, because polynomial means many terms. And so any of these, so quadratics are still considered polynomials, so are cubic, but we're still going to learn a strategy for factoring certain cubic expressions. It won't work for all of them. So what we're going to do is we're going to just create a box. We've got 4 terms. We've got 4 parts of the box. So you're going to put a term in each square. Now, it will matter what order. I usually do them in descending like this. If you mixed them all up, you could end up with a problem. So here I'm going to do GCF factoring, so I can pull out a 2 and I can pull out an x squared. Then this is going to be a 2 and an x, because 2 times 2 is 4, x squared times x is x cubed. This would be a minus 1, so that works. This would have to be a negative 7, so that works, and negative 1 times negative 7 is 7. So I get 2x squared minus 7 times 2x minus 1. Now, before I go on, I would always want to check, especially this first factor here, is 2x squared minus 7, because I notice there's a minus. Is it the difference of 2 squares? Well, no, because 2 is not a perfect square and neither is 7. But you want to check for that, because sometimes you do your initial factoring with this box and there's something else that can be factored. Okay, so this one, again, we got 4 terms. This is a cubic polynomial, so we're going to have 7n cubed, negative 4n squared, a 14n, a negative 8. So if I pull out my common factors, I can't pull out any numbers, but I can have an n squared, which means this is a 7n, and this is a minus 4. This would have to be a plus 2. 7n times 2 is 14n. Double check, negative 4 times 2 is negative 8, so that works. So I get n squared plus 2 times 7n minus 4. And again, I check this n squared factor, and it's not the difference of 2 squares. Even if this had been a 4, n squared plus 4, this would have had to be the difference of two squares. There is no formula for the sum of two squares, but it's not a 4, it's a 2. Okay, the next one. So I'm going to have an x cubed, a 2x squared, a minus 9x, and a negative 18. So I pull out a common factor, which would be an x squared, which means this would be an x. This would be a plus 2, so I multiply it, makes 2x squared. This would have to be a negative 9, and I double check the last box. 2 times negative 9 is negative 18. So I get x squared minus 9 times x plus 2. But wait, this. X squared is a perfect square. 9 is a perfect square. This is the difference. So this is the difference of two squares. Remember the formula? A squared minus b squared equals a plus b times a minus b. If you are not familiar with that, you need to go back and watch video 2. So I get x plus 3 times x minus 3. That would be how I would factor x squared minus 9. But I already had the x plus 2, so that still has to be here. And this is my factorization of this original expression. Next one. Notice I have two variables. I have a u and a v. Not a big deal. So I'm going to put 30 uv, 35 u, negative 36 v, and a negative 42. Now, when you have two variables, you will want to make sure that the constant still goes in the bottom right, and then the expression that has both variables, put in the top left. So I'm going to look for GCF, so I can factor out a 5u, which makes this a 6v, because that would give me 30 uv, which means this has to be a plus 7. This would have to be a minus 6. 6v times negative 6 would be negative 36v. Double check, 7 times negative 6 is negative 42, so that works. So I get 5u minus 6 and 6v plus 7. So this is actually a polynomial in two variables. We're not really having that be an emphasis, but you can still use this factoring method for problems like this. And then this one. Now, when you put the numbers into the boxes, what I just said, remember, was the constant should go in the bottom right. So I'm going to put that here, even if it's not the order they gave me the problem in. My 24mn should go here. Then I'm going to have a negative 18m. This part wouldn't matter. The negative 28n. So if I had switched those around, that part wouldn't matter. So now I'm going to pull out common factors. So I can pull out a 6m, which makes this a 4n, and this a minus 3. And then I would need this to be a negative 7 to get negative 28n. And double check, negative 7 times negative 3 is a positive 21. So I get 6m minus 7 times 4n minus 3. Remember, you can double check any of these. If you multiply this out in a box or you FOIL it, you can double check to make sure that you got the right answer. So that is called factoring by grouping, and pretty simple.